Good morning, everybody. Let's go ahead and talk about your assignments for this week and then jump into our lesson about the solar system. First, you guys are going to work on this activity. It's called Lost on the Moon. Basically, you're going to pretend that you're part of a space crew that crash lands on the moon, and somehow you got to survive long enough to get back to your crew somewhere else on the moon. And there are going to be these 15 items that you have available to you. And basically, in the assignment, you're going to rank those items in order of importance. So you will be able to give your opinion why you think these items are valuable or not valuable at all. You'll basically go through the assignment, list the items in order 1 to 15, and then at the end, you'll write a little bit about why you ranked each item the way you did. And basically, it's all for the goal of surviving on the moon and getting back to your team safely. It's kind of an interesting activity. I think it'll be fun. There's no real right or wrong answer. You just have to give your opinion on this whole thing. Tuesday, there's an ed puzzle you'll be doing about terrestrial planets. Wednesday, there's an ed puzzle you'll be doing about Jovian planets. And then Thursday, you're going to do a planet profile. It's basically a little bit of research. You get to pick any planet you want in our solar system, except I don't want you to pick Earth because we're going to have a whole unit on Earth later. So pick any planet you want. And you can even pick Pluto, which is no longer counted as a planet. It's a dwarf planet, but you are allowed to pick Pluto if you choose to write your profile about Pluto. So any planet except Earth, and you can also pick Pluto. And then Friday, there's no school this week, as well as no school the following Monday. So you get a 4-day weekend. So that's going to be awesome. But that's what's going on this week. Let's go ahead and jump into our lesson about the solar system. Well, it is estimated that 99.85% of the mass in our solar system is completely contained right there within the sun. Another important thing to know is that our planets, they all travel in the same direction around the sun. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and even Pluto, which is no longer considered a planet, it also travels in the same direction. They all travel around the sun exactly the same. So in our solar system, we have what are called the terrestrial planets and the Jovian planets. Well, the terrestrial planets, which are very Earth-like, they're solid, rocky. Those are our inner planets. Those are Mercury, Venus, Earth, and Mars. And we have the Jovian planets, which are more Jupiter-like. They're made of gas. They're not solid. These are huge, 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 huge gas giants. They are called, also known as the outer planets. Well, these are Jupiter, Saturn, Uranus, and Neptune. And then Pluto, it doesn't really fit into either category, which is part of what factored into the decision that made it not considered a planet anymore. But it doesn't really fit into either of those categories. It's kind of its own thing. It is a dwarf planet. Well, size is the most obvious difference between the terrestrial and the Jovian planets. If you look at this picture here, you can see, well, first of all, the sun. This is only showing us like a tiny little portion of the sun. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and then even Pluto, even though it's not a planet, the sizes are very different. So that's kind of the most obvious difference between the inner planets and the outer planets. The outer planets are way bigger. Now, Earth has the largest mass and diameter of the inner planets. So of all these inner planets or terrestrial planets, Earth is the biggest. In the outer planets, Neptune is the smallest. It has the smallest mass and diameter of the Jovian planets. And then Earth's diameter is 1/4 the diameter of Neptune, and Earth's mass is 1/17 the diameter of Neptune's mass. So the biggest inner planet is still like 1/4 of the diameter of the littlest outer planet, just to give you an idea of how big of a difference there is there. So density, chemical makeup, rate of rotation, these are all other ways that the two different groups of planets differ from each other. The terrestrial planets are 5 times denser than even water. and the Jovian planets are about 1.5 denser than water, 1.5 times denser than water. So they have vastly different densities. That's another way that they differ. So what's inside the planets differ as well. So the substances that make up the planets are divided into three groups. We either have gases, rocks, or ice. And when we say ice, it could be frozen water, but it also could be frozen carbon dioxide, frozen methane, frozen ammonia. And the terrestrial planets are mostly rocky and have the metallic substances. And the Jovian planets are mostly gaseous or icy. So that's another big difference, is the stuff that makes up these planets also is a way that they differ from one another. Now, the atmospheres, the Jovian planets have a very thick atmosphere, either made of hydrogen, helium, methane, or ammonia. The planet's ability to retain an atmosphere depends on its mass and temperature. So Jovian planets have way greater surface gravities. And then by contrast, the atmosphere of terrestrial planets only makes up a very small portion of their total mass. So the Jovian planets are so big because their atmosphere is part of the planet. Now, Earth, Mercury, Venus, Earth, and Mars, the terrestrial planets, the atmosphere isn't really considered part of the planet. So that's another reason they are vastly different in size. Okay, we have the nebular theory, which is one way that explains the formation of our solar system. So a nebula is this big cloud of gas or dust in space. And according to this theory, the sun and planets all formed from one of these rotating disks of dust and gas in outer space. Like the Big Bang began this disk, and then everything that we have came from it. That's the theory here, the nebular theory. All things that we know of came from these rotating disks of dust and gas. And over the, millions and millions of years, it formed into what we know today. Again, that's the nebular theory. And then we have planetesimals. So the growth of planets begin as solid bits of matter that begin to collide and clump together in a process called accretion. So again, accretion is when all these things start to just collide together and clump together into one thing. And these colliding pieces of matter, what they form are these irregularly shaped bodies that we call planetesimals. So those clumped together masses, we call those planetesimals. The process is called accretion, and what they produce is called planetesimals. With more collisions, the planetesimals grow larger until they exert a gravitational pull and become planets. At some point, they get so big that they have their own gravitational pull and they become planets. The inner planets grew from substances with high melting points, and the outer planets grew from solid bits and ice and gas, things with lower melting points, which hopefully that makes sense. They're farther from the sun, so they're able to be made out of colder things. Well, let's kind of look in depth at each of the planets. First, we have Mercury. It's the innermost planet. It's the smallest planet. It's not much bigger than Earth's moon. It has the greatest temperature extremes of any planet, meaning one side that faces the sun is so hot and the side that faces the opposite of the sun is so cold. Those extremely differences are the biggest differences of any planets. Mercury has cratered highlands, much like the moon. It has vast, smooth terrains that resemble Maria. Eventually we'll talk about lunar Maria when we get into the moon. Venus is the next planet. Its surface temperatures reach about 475 degrees Celsius. That's very hot. And its atmosphere is 97% carbon dioxide. So we could not breathe there. Venus is similar in size to Earth. It is similar in density as well and mass. And its location in the solar system is pretty close compared to the other planets. So it's been referred to as Earth's twin. It has its major differences, but it's very similar compared to the other planets. On the surface, it's covered in thick clouds that visible light cannot penetrate, and about 80% of Venus's surface consists of plains covered by volcanic flow. So if you were to look through a telescope, you would see lots of volcanic flow happening on the surface of Venus. Okay, in our solar system, Earth is the next planet. It's the only known planet to contain intelligent life. It has liquid water. We could say so much about Earth, but we're going to discuss Earth in much detail in its own unit. So we're not going to focus on Earth so much, but it is a terrestrial planet. Next is Mars, the red planet. The Martian atmosphere has only 1% of the density of Earth's. So although the atmosphere of Mars is very thin, extensive dust storms occur and can cause these color change observations from Earth. That's why it appears red sometimes. Most Martian surface features are old by Earth standards. The highly cratered southern hemisphere is probably 3.5 billion to 4.5 billion years old. Some areas on Mars exhibit drainage patterns similar to those created by streams on Earth. And these images from the Mars Global Surveyor indicate that groundwater has recently migrated to the surface. So that's pretty interesting. Next, we're going to move on to the outer planets plus Pluto. So we have the gas giants, Jupiter, Saturn, Uranus, Neptune. Jupiter is the largest of the Jovian giants. It has a large red dot, which is actually a massive storm that's going on. We were able to view at some point there was this comet crash onto its surface. But that's Jupiter. It is the largest, not only the largest of the Jovian planets, it's the largest of all of our planets. Saturn, it has these horizontal rings. It rotates so fast, which kind of causes it to flatten and bulge a bit at the equator. It's the least dense. It would actually, if you were able to capture it and shrink it down, it would float in water. That's how small its density is. Uranus, it is a superheated ocean of water, 8,000 kilometers thick, so that's a lot of water. It's a blue planet with atmosphere features and around 11,000 kilometers thick, and its axis is tilted about 90 degrees. Neptune, its orbit was used to calculate the position and existence of Pluto. It has 5 vertical rings that we don't always see, but they're there. It's a blue planet with atmosphere that's visible. We can see the visibly changing clouds. Its largest moon is Triton, which has retrograde revolution. Now, there are a few other minor members of the solar system that we should know about, such as asteroids. So an asteroid is a small rocky body whose diameter can range from a few hundred kilometers to less than a kilometer. Most asteroids lie between the orbits of Mars and Jupiter, and they have these orbital periods of about 3 to 6 years. So asteroids have these really irregular orbits. If you look at these pictures, some of these circles here show some weird, strange orbits of some of the asteroids. We also have this asteroid belt full of tiny little asteroids, but some of them have their own course and they're very irregular. There's no rhyme or reason to it. We also have comets. Comets are these small bodies made of rocky and metallic pieces that are held together by frozen gases, and they generally revolve around the sun in pretty elongated orbits. If you look here, we have like the anatomy of a comet with what we call the nucleus in the middle, the coma around that. There's a hydrogen cloud and a tail. So again, yeah, the nucleus in the middle surrounded by the coma. Then we have the hydrogen gas and the tail flowing behind it. And the tail always points away from the sun. That's an interesting fact about comets. So the coma is the fuzzy gaseous component of the comet's head. It has a small glowing nucleus with a diameter of about a few kilometers and can sometimes be detected within the coma. As comets approach the sun, some, but not all, develop a tail that extends for millions of kilometers, and a comet's tail always points away from the sun. So comets come from a couple places. We have either short period comets or long period comets. The short period comets come from the Kuiper belt. Like the asteroids in the inner solar system, most Kuiper belt comets move in nearly circular orbits that lie roughly in the same plane as the planets. And then long period comets come from a place called the Oort cloud. Comets with long orbital periods appear to be distributed in all directions from the sun, forming a spherical shell around the solar system called the Oort cloud. So again, comets either come from the Oort cloud or the Kuiper belt, and this comet sphere was proposed in the 50s by Dutch astronomer Jan Oort, which is why it's called the Oort cloud. But you can see the solar system here, and then if this sphere would be the comet sphere that it's talking about, if this is our entire solar system. Now, the most famous short period comet is Halley's Comet. You've probably heard of it. It orbits about every 76 years. It passed Earth in 1910 and again in 1986, and it's going to pass again in 2061. So for us, that's about 40 more years from now. We also have what's called meteoroids. A meteoroid is a small solid particle that travels through space. A meteor is the luminous phenomenon observed when a meteoroid enters the Earth's atmosphere and burns up. We typically call these a shooting star. And a meteorite is any portion of a meteoroid that actually reaches the Earth's surface. It does not burn up all the way and actually makes it to the surface. That's a meteorite. Most meteoroids originate from any one of the following three places: either interplanetary debris that was not, gravitationally swept up by the planets during the formation of the solar system. It could come from material from the asteroid belt. It could also come from the solid remains of comets that once traveled near the Earth's orbit. And that is your lesson about the solar system. If you need to go back and refresh your memory on some of this stuff, go ahead and rewind the video, watch it again. Otherwise, refer to it if you need to. Good luck on your assignments for this week, and make sure that you email me if you have any questions.